Okay, let me get a grid up here. All right, so 0, -5, 1, 2, 3, 4, 5 is point F, and -4, -3, 1, 2, 3, 4, 1, 2, 3 is point F prime. All right, so wherever, again, let's review. Wherever this line's going to be, it's going to be the what of F and F prime? When I draw this line of reflection in here, that line is acting as the what for F and F prime? Perpendicular bisector. So let's take care of the perpendicular part first. First thing I need to find is the slope of F prime. So what is the slope from F to F prime? Well, I go up 2 over 1, 2, 3, 4, up 2 over 4. So that's what, 1/2? But as you notice, is that a negative or a positive slope from F to F prime? That is a negative slope. So what would be your slope of your line of reflection then? If these two are perpendicular, it should be positive 2. All right, so they're negative reciprocals of each other. Also, this line of reflection is going through the what of F prime? The midpoint. So I need to find the midpoint of F and F prime. So the midpoint, I take my two x coordinates and add them together. -4 plus 0 divided by 2. And then I add the y's, -3 plus -5 divided by 2. So it's -2, -4 for the midpoint. All right, so I know the slope's 2. The only thing I'm missing is the y-intercept. To find the y-intercept, I use y equals mx plus b. Anybody know a y coordinate it goes through? This is why I found the midpoint, by the way. What's a y coordinate this goes through? -4. The slope was 2. X coordinate it goes through is -2. I'm going to solve for b now. -4 equals -4 plus b. Add the 4 over, you end up with b equal to b equals 0, I believe. Did I do that right? Not missing anything, am I? 0. So what's the equation of this line? Y equals, what was the slope? 2x. You can put plus 0 if you want, but that's it. How do I get 2x minus 5? Any ideas? I don't think I did. F prime, no, I can't go F, yeah, that's incorrect. It should be y equals 2x. That's the right equation. Others that you wanted to go over on the review at all? Yep, Mike?
Part C on 28.
Graph and label or reflection on the line y equals x. Nope. That's the next problem. Graph and state the coordinates of a dilation of 2. Yeah. Okay, so you have the coordinates of A prime, B prime already, right? Okay, everyone help out here. What do you do if you dilate by 2? What do you do with your coordinates if you're dilating them by 2? Multiply each of the coordinates by 2. So whatever your coordinates were in part B for A prime and B prime, we'll take those coordinates, multiply it by 2, and you'll have double prime, A double prime, B double prime. What's that? No, it's the same. Remember, it's the same line. Just the points are different. Okay, the points are different. Other questions? Okay, I don't know. Like at times I get frustrated because I don't know if it's my fault, if it's partially your fault. I'll take the blame as usual, but I don't know what to do with these constructions. Because I remember for the quiz, I had you guys translate one and people are reflecting it over a line and I'm like, what is going on? All right, so I'm going to allow this time here, even though all of these are up on Aspen and you know where they are to see the videos of them. Are there any here that you want me to do? Because all of these are fair game. 1, 2, 3, 4, 5, 6 of them tomorrow are fair game. Okay, and I can tell you there's going to be more than one on there. Will? Okay, so you want to dilate. You got to give me a scale factor you want to dilate. Okay, so dilate a scale factor of 2. I believe that's on the, did I put that on the review? I know there's one dilate. Yep, there you go. Dilate a scale factor of 2. I think just memorizing the steps doesn't help you. I think you have to really understand what is happening right now. Here's point A. It's a certain distance away from P. What's about to happen to that distance? It's going to double its distance away. Not on the other side, on the same side. So take a look. A should be somewhere out here. It's not getting closer to P. It's getting further away. It's doubling its distance. So if I want to double my distance for point A, there's the distance right now. I'm going to draw a line right through A because I'm about to copy that distance over. So here's the distance from A to P. And again, I'm going to copy that distance on the other side of A. And I should get A prime right there. A prime. And then I'm going to do the same thing for D and B. So D is going to get further away. B is going to get further away. It does not get closer. It does not go on the other side of the point I'm dilating through. All right, it does not go on the other side. It stays on the same side. Just gets further away or closer if the scale factor is between 0 and 1. Amy? Everyone all right here? I'm just going to do a point here because that's really, if I want to answer everyone's questions, that's all I have time for here. So here you go. Translate it along the vector. Everybody, what are you doing when you translate? Sliding. This is what drives me bonkers. Why should this triangle be on the other side of the line? It shouldn't. None of it should be on the other side of the line. Not even close to it. All I'm doing is taking this triangle and sliding it in this direction, that distance. So it should end up somewhere up here, never on the other side. All right, so which point do you want to translate? Let's go B. All right, let's translate B. First thing is I measure the size of the vector. Measure the size of the vector. Then I go and put it on the point I'm translating, which for us right now will be B. Again, does it make any sense for me to make an arc over here? It's not sliding over there. All right, I'm going to make it on the other side right here. So I'm going to make an arc right here. And I know now that point B prime's got to be somewhere on there. Okay, it's got to be somewhere on there. Where on there? Here's the second helping of steps. Put your compass point on the end of the vector and point B. Measure that distance from vector to B. And then anybody remember where I put it now? At the end of the vector, the tip, yep. And that's where it should intersect that first arc that you made. So there's B prime in the correct direction. It should not flip over the line when you translate. And then measure the vector again. Go to A, make your arc. Beginning to A, tip to arc. Warning for you guys, a little warning. Where's my... Not all of these are in the review packet. Okay, I can tell you finding the line of reflection is not in the review packet, and neither is finding the center of rotation. So you either have to go back to your own notes or rewatch the video, or we can talk about it. It doesn't matter, but I'm just giving you a warning. Not all 6 are in the review packet. Yep. Finding the center of rotation, sure. I'm going to have to just make this one up. Okay, finding the point where I rotated it around. First step, you connect 2 of the corresponding vertices. So C, C prime, B, B prime, A prime. Doesn't matter. Connect a pair of corresponding vertices, then do the perpendicular bisector for that one. Open it up, draw your perpendicular bisector in. Do it for another pair of corresponding vertices. Same exact thing, do the perpendicular bisector for it, and where they intersect. So if I go B prime now, hopefully I can open this up wide enough. That doesn't look halfway yet. I'm gonna have to go with it. And then connect my perpendicular bisector, and then again, where these 2 bad boys intersect will be my point of reflection. So there it is right there. There's my point of reflection. Oh, sorry, rotation, excuse me. And I never will ask you the degree you rotate because protractors aren't required. Yep.
I'm sorry, do you have any way to remember which construction is for which thing?
Practice, practice, practice.
All right, thanks.
And when I say practice, I don't have to give you something. If you want to learn how to rotate, you draw a triangle, put a point, rotate around it. Okay, this is nothing like I can give worksheet after worksheet after worksheet. Constructions are literally you draw a figure, graph a line or a point, rotate, reflect around it. All right, it's just reps. Okay. Will? Okay, here we go. Rotate around a point. In this case, 90 degrees. All right, again, before you start tomorrow, think about where this darn thing should end up. 90 degrees, it tells me in which direction? Counterclockwise. So I need A to be over here, D to be over here, B to be over here. Start thinking about where this should end up. Everything should be counterclockwise direction. So let me do point A with you. All right, so if point A needs to rotate 90, I need a perpendicular line going through AP. Not just any perpendicular line. It's got to go through P too, because it's got to form 90 degrees if that's where I'm rotating, 90 degrees. So where do I put my compass? On point P. Make an arc that intersects in 2 spots. Open up your compass or close it or keep it, doesn't matter. Go to each point of intersection now. Then you have your perpendicular line. Which direction were we rotating again? Counterclockwise. So should this go to our left or our right A prime? To our right. If you were going 270, which I don't think I would ever have you do, but 270, yeah, now you do it down here. All right, now how can I find where A prime's going? Angle measure is preserved, and what else is preserved in any rotation? Distance, meaning the distance from A to the point of rotation is going to be the same from the point of rotation to A prime. And there is A prime. If I asked you for 180, because the only other thing other than 90 I would ask you for is 180. Everyone see on my construction here where I would put A prime for a 180 degree rotation. Right here. I would measure that distance here and copy it over here because 180 is a straight line. Okay, so 90 and then 180 is here. Maggie. So you want another dilation? Are we like same scale factor of 2, or you want to cut it in half, or? Anybody have a preference? Whether it's 2 or 1/2 or 1/2? Okay, so I'll do C first. So what's going to happen to C? Is it going to get closer or further away from P if I'm dilating by 1/2? It's going to get closer. All right, it's going to get closer to P. How do I find half that distance right there that I drew in? What am I going to have to do to PC? Yep, by doing the perpendicular bisector construction. Shoot. And then where it crosses. And again, I think I talked 2 days ago. You don't need to draw in the full line. You can just line up your straight edge and mark the midpoint or halfway. And there's C prime. If I was doubling my distance, I would extend this line, copy that segment over here. If I was doubling the distance away. guys are having good questions here. Other than, I know we've been focusing on constructions, but there is other big portion of the test here. Anything else that up here that you wanted to talk about? Yep, Will?
We did this yesterday, but like point symmetry.
All right, so point symmetry. Well, I'll start with letters here. So letters that have point symmetry, S, Z, but they don't have line symmetry. Okay, you start now talking like H, X, I, they have both. All right, how do I know what point, if a figure or a letter has point symmetry? What should I be testing? Turn it upside down, it's the same letter or figure I started with. Let's point. Line is you just draw a line somewhere and it can flip over. Vertical, horizontal, diagonal. Any line you can draw in, it has line symmetry. Okay. I'm trying to think ones that have line but no B has line symmetry but no point symmetry. All right. Anything? Reflecting through a point. If I give you a point and say it's 2, 0 and reflect through 5, 8, how you can reflect through the point. If you can't just simply count how many units away it is. Anybody remember what we did? Here you go. So you had let's say I have point A right here, and I would like to reflect it through this point right there. How do I find A prime? I know it's got to be on the other side, so it's got to be over in quadrant 2 somewhere. Anybody remember exactly how to find it? Use what? Slope, right? Up 1, 2 over 1, 2, 3, 4, 5, 6. Up 2 over 1, 2, 3, 4, 5, 6. There's A prime. All right. Yes, Amy. Rotated 180? Yeah. Okay, remember what 180 is again. It's a 180? Oh, no. 180 is just a straight line, right? Yeah. So all I'm going to do here is, okay, let's say I wanted to rotate point B 180 degrees. So all I'm going to do is draw a straight line there. And what angle measure doesn't change, which I just did. And what else doesn't change with the rotation? Distance. So I'm just going to measure BA over here. Same thing with D, L, and C. Just make sure it goes on the other side of your straight line. Distance doesn't change. Yep.
On the paper they just had up, it said under rotational symmetry, like magnitude and order.
Yep. Okay, assuming all those triangles are the same. They're all congruent. This does have rotational symmetry. All right. Order. How many times can I turn this figure all the way around and see this same figure again? So I turn it all the way around. How many times would I see this drawing as I rotate from 0 to 360? I'd see it 3 times. That's called the order. How many times you'd see it from 0 to 360? Magnitude. is the smallest degree measure you could rotate this figure and get it back, which is found by doing 360. And then how many times did you see the figure as you turned it all the way around? 3. So that would tell me anytime I go 120 degrees, the smallest angle measure you could rotate through. Is that the only angle measure? Nope, you could do 240, but the smallest one is referred to as the magnitude. Anything? I like all the questions. Anything else we want to cover? I know there's a lot on there. It was a big unit. Just make sure we know the correct wording if you're going to do a proof tomorrow using rigid motions. Again, remember, rotations, translations, reflections are not good enough. You need to tell me more specifically what you're doing with them. Do you want the rest of the time for yourself then? Okay. You guys know the answer keys up online already, so you can check those. And again, last warning, all these reflections are not in your packet, so you might want to look back in your packet or on the videos to see how you did it, or ask me within the next 12 minutes here.